Hello guys, welcome to Zip Code, and today we are looking at system design or system architecture, and we want to contrast between a monolith and a microservice architecture. We're not looking to code, but as usual, you know that if we discuss a topic, we'll go through and do some code on the next video. So for now, without wasting any of your time, let's have a look at what a monolith or microservice is, the pros and cons that have to do with a monolith and a microservice, contrast between the two, and also go into the use cases of which one to use in what situation on your project, and then which one you can decide on, or which one is much more preferable overall in terms of system design or software development um, standards. So without wasting any time, let's check this out. So first things first, we want to start with what is a monolithic architecture. So a monolithic application is basically a single-tiered application that is designed to be self-contained, meaning multiple components or all the components are combined into one large application, and these are tightly coupled components, and they need each other in one code base to basically work together as a unit to deliver that particular business requirement. So all the business units are in one application, and if one of the components could fail, it can impact the entire application. And any change that happens on the application or an update that needs to be pushed, it has the entire application needs to be deployed for that change to take effect, which means any small change that can happen on the application and a deployment is required, or a change is required, the entire application will be down, and deployment takes effect, and then that basically would impact your service, and clients obviously would not be happy about that. So if you are using, let's say you're building an e-commerce, and you using a monolithic architecture, in the e-commerce, you know, you have an order processing, and you have payments processing, and you have customer registration happening within that whole mix of things. So if one component needs to change, say you're changing the payment method on your e-commerce site, then the entire application needs to be deployed for that change to take effect, which is a bad design if in software development standards, I would say. But that's basically what a monolithic architecture is. So now going further, we want to see what a microservice is, or a microservice architecture is. So microservices are multi-tiered sort of applications. So the services are independently deployable, meaning the multiple components live in their own service and with their own code base, as well as stack and team. So what this means is, in microservices you have small single services that are doing one specific task that is dedicated. They interact where they need each other to deliver a particular business process. So all these services are loosely coupled components. They can be developed in different languages, and they solve for one business unit or domain specific components. That's basically what we have in the microservice architecture. So each service will be deployed separately, as it is not tied to any other service, and they can interact with each other wherever they need. And when it comes to the deployment downtime, only the service that is being deployed can have that minimized downtime, but not the entire application. So all other components can be working. In the example of an e-commerce, if you're changing the payment backend that you're using, you only deploy the payments microservice or the payment service alone, and every other feature within the system will still be working fine, and only that service will be impacted. And then that is what a microservice architecture sort of is. And also when it comes to scaling, just to stretch it a bit, when it comes to scaling, um, you only scale where you see that there's a high demand of resources, or where there's high traffic, you scale that particular service, and that scaling would only be impacted and nothing else. Everything can remain where it is. The infrastructure can remain as is intact, and when there's a demand, then it can scale up according to the demand to meet the traffic, and also those costs will be minimized, as opposed to a monolithic architecture where if there's a high traffic coming to your application, then you have to scale the entire application. Obviously all the components are in there, so um, the infrastructure cost will be so high because a lot of services would be using a lot of the resources, even though some of the components do not really need those resources. But yeah, that's basically the contrast just between the two. So going further, let's see the pros and the cons of a monolith. So the pros is easy deployment. So you have a single deployment for updates. So it's just one deployment and that's it. You don't have to deal with multiple deployments happening all over the place. So you do one deploy for updates and that's it. And then when it comes to the performance, so a single API can do more functions, which means it can once a single API can take more responsibilities and deliver much more functions in the entire process. And then the other one is development. So because this is a single code base, you can basically make the changes there, and it also becomes much more easier when the developers know the code base through and through, because they wouldn't be stepping on each other's foot in that sense. So also when it comes to debugging, if an API has an issue, because this is a single code base, it's easier to get the root cause. You just check the payload of that particular API, go directly to it and address it at that level, and then the fix is done, and it goes further into testing and all that. But when it comes to a microservice, it's a different story, because when it comes to debugging, there could be multiple APIs involved in delivering one business process. And because there are multiple APIs, you wouldn't just know offhand which API is broken. So you need to check all of those services in between, or the integration points that are happening in between, for you to find the root cause or find the faulty service, and then go address it at that level. And then once the service is back up, then the entire business process should be running as smooth or as expected. So the cons of a monolith is basically slower development, because a small complex development um, um, it is caused by the large code base. Basically, as the code increases, the complexity increases, and the code base becomes hideous to maintain or manage, and basically that will lead to slower development, because all the components are basically talking to each other, and that complexity is in the mix. And then when it comes to reliability, so a single module failure can affect the whole application. So as I've mentioned earlier on, so reliability is the biggest factor, especially when it comes to a client-facing application. Clients would really want an application that is highly available all the time, and when they query certain components, they want that speedy response and all of those. So a single failure can affect the entire application, and to get that fixed and do another deploy would still cost you to take down the application and do a deploy, which will delay the entire user experience basically. So when it comes to scalability, you always scale the whole application instead of single components. So you don't scale one single part where maybe it's ordering and payments that require to scale up or scale horizontally. You basically scale the entire application, like I mentioned, which is just would impact a lot on the costing side because you scaling the entire application for no particular reason. But when it comes to microservices, you only scale the services that are on high demand, and that's it. So the costs are sort of managed in that sense. And then when it comes to deployment, so a small change requires an entire application to be deployed. And if with the example that I used on the payments, if you change a payment method, then the entire application would need to be deployed so that that change could take effect. Which are the cons of a monolith? Now going down to the pros and the cons of a microservice. Um, so a microservice is a flexible scalability. With the example that I've been using, you change one particular service, you deploy that particular service independently, or you scale that particular service independently. You don't need to scale all services within your architecture. So every service is independent of itself, its own infrastructure, its own language, its own logging mechanism, its own monitoring tools. So all of those, they can be dedicated to one particular service, and they can be addressed at the service at that particular service level. And then agility. So agile teams for changes and updates rollouts. So because there are multiple teams working on multiple different services, these teams will be dedicated to one particular service each, and they will have their own changes and updates that they would want to roll out once, twice, 3 times a week. And this will actually enhance the delivery and quick to market sort of rollouts that you can have as a team. And then the continuous deployment, multiple small deployments for changes. So any change that is done can be deployed as and when the team requires. So this continuous deployment is much more effective when it comes to delivery and meeting the high level of performance that the system can reach. And then reliability is failure of service does not impact the entire application. So one service failure does not impact the entire application. You just address it at the service level, and you deal with it at that level, address it, address the bug, put it to test, and then testers can approve and sign off, and then you can deploy that change effectively. So the entire system will still be intact, even though that particular service might be affected on its own as a single unit. And basically, those are the pros those are pros that we have in the micro service architecture. And then on the cons, we have development sprawl. So basically, on development sprawl is slow development if the team does not properly communicate. So this requires a lot of let's say stand-ups, team meetings, technical impact analysis, system analysis, and all of those. So once the team is able to find synergy amongst each other, the development will be much quicker and much faster, because each team would know what it needs to do. And also when it comes to the timelines, they can sort of interact between each other. And if there's any delay, they can sort of communicate the delay in due time, so that the entire process is not delayed, or the development process is not delayed. And then when it comes to infrastructure costs, because each service can have its own infrastructure and tools, the costs will be separated, and they would be handled in that sort of a fashion. Each service would have its own billing, and it has to be addressed at the service level accordingly. So this can just be a con that you can have when it comes to the costs and the financial side of it. And then with the debugging challenges will be root cause can be complex, as some processes can run across multiple services, as I've mentioned this. So to debug the entire process would need you to also confirm that all other services are working fine, and then if they are, and then which one is broken, then go to that one, address it at that level, and the issue should be resolved. So that's basically one challenge that you can have or face when it comes to the debugging of it. And then lack of standardization is different services can be developed in different languages, stacks, logging standards, as well as monitoring tools. So when it comes to I wouldn't say lack of standardization per se, but you say each service can have its own dedicated stack and standards, of which it won't be the same standard maybe across the organization, but in terms of the communication across the services, that should be fine. But when it comes to debugging and monitoring, could be different tools, which then would give that complexity at that level to address issues and then drill down into root causes and all of those type of concerns. So basically, that is what we have for microservice. And then going further, we have use cases of a monolith would be small limited functional requirement application that needs quick deployment. So this would be just an application to address one business requirement, and nothing complex, nothing large. You can use a monolithic architecture to solve for this particular use case. And then simple applications with predictable scalability and complexity. So there's no massive rollout that would happen on this application. It's much more targeted or small users or within the company or a small company, then you would use such an architecture as well. And then proof of concept and quick launch. So you just want to showcase a product or an application, and also you want a quick launch to sort of gain traction on the application and see user feedback or client feedback. You can sort of use a monolithic architecture and then grow from that point on into a microservice architecture, where you can do a big and a massive rollout, where you can expect high traffic and high demand on the application. So the entire application can meet demand on a single server. So basically, there is not much of a demand, or it's much more dedicated application, and all the users can use or access that particular application using small infrastructure or a single server. Essentially, this would solve for a monolithic architecture, and that's basically what it is. And then going further into use cases of a microservice architecture. So this one is basically for large enterprise applications. So application is expected to grow significantly over time. So large, complex, and diverse functional requirements, divided components into more manageable small services. So modular systems allow teams to be more dedicated and collaborate on their business requirement. So the different components are divided into smaller teams that can focus on each service independently, and then be able to collaborate on the business requirement and which team needs to contribute what service in the bigger picture or the bigger scheme of things. So, and then the application requires high availability and minimized downtime during deployment. So this would be a mass delivery or a mass deployment large enterprise application. So you want high availability because you're serving multiple or a large pool of users. So you'd want high availability and minimized downtime during deployments, and high performance and reliability of the application. So you would use a microservice architecture to solve for big complex systems or software solutions. And essentially, that is what we have on these use cases. So overall, which architecture is much more preferable or advisable? I would say, as both architectures solve for different use cases, they can both be prioritized based on the business needs. However, it is advisable to follow a microservice architecture over monolithic architecture, because when the demand of a service increases, the scalability on a microservice architecture is much easier than on a monolithic architecture or application. So, and also it goes further into the collaboration and the service delegation to specific dedicated teams for each business unit can enhance the development times as well as delivery times. So as the user base of your application grows in a microservice architecture, you can scale according to the need or according to the demand. But on a monolithic architecture, you would face the same issues that Netflix had faced previously, where they had to now change their entire architecture to a microservice architecture instead of a monolith, because the traffic was so rapid and so significant that the monolithic architecture was not meeting the demand, and they were forced to that particular corner, and eventually into them even winning an award for their undertaking of the or adoption of the microservice architecture, and they were so good that they even won that particular award. So if you anticipate such a growth in the application, or you know that this um, is a mass release application or product, I would suggest you go with a microservice architecture, so that when these concerns or when these hurdles come about, you are already at par with what's about to happen. You can anticipate the growth, and you can just plug in a much more efficient infrastructure as soon as possible without changing the entire architecture of your system. So also, one thing that I want to highlight on is the integrations with other external systems can be clearly defined, and each service can have its own integration points independently managed, and these can be known to that particular service and not the entire application, and they can be handled at the service level and not the entire application. So going further onto our last point is the logging as well as monitoring can happen independently for each service, and that can be dealt with much more easier. Once an issue is identified, it can be dealt with at that service level, and with all the monitoring tools, they can be able to diagnose and be able to log and address bugs at the service level. So that's it for now, and that's it for me. Thank you for watching. Please do remember to like and subscribe. Until next time, cheers.